debugging. And then the last thing, once I know it's all working just beautifully, then add in that piece of interaction.
Okay. And we're reading in one file, right?
Pardon me?
We're reading in that only one file, so technically.
Correct, correct. But it should be named, be able to name it just about anything you want as input. But it needs to be a text file.
Just suggestion for anyone just starting. If I were you, I would start with a smaller file, a much smaller one, because it's much easier to debug. That's what I do.
I gave you an example of that earlier on, right? With the Bill Cosby quote. You could read it from the file.
Like lab 3.
Yeah.
Okay.
The structure.
There are some issues about punctuation and things beginning with digits. They're not words, so they're not separated out. So you need to find that out. Depends on how you want to approach it, whether you use straight searching for spaces, or if you do use the string toke to drive it all. It's kind of a big one for string toke, but certainly it can handle it. Okay. Other questions? All right. So I want to continue on. Now in the slides, chapter 14, I think we were somewhere around here. Had we started on the string class yet?
You were going
No.
over the disadvantages of object
Had
oriented.
we talked about generic programming? That was the very end, I think. The idea of being able to create a template, for handling whatever data structure you might be working with, regardless of the data types that are involved in that data structure. So we talk about an array and processing an array, traversal of an array, but we don't know what the data type is of that array. Could be an integer array, could be a character pointer array, could be just about anything, and the template class allows us to define that and traverse it, pick something out of it, whatever, and change as a parameter, change the data type of the values that are stored in there. Another one where we use it quite often is in linked lists, where we have things chained together and the data that's in there may be of a different varying type. We have a class, though, that we can simply reference to walk down a linked list or a binary tree or some complicated data structure where the data type of the things that are in that data structure are passed in as parameters. Very powerful tool, very powerful tool to be able to use. Write the code for a binary search tree one time as a template, and then never have to worry about all the logic of it again. Simply passing in the data types. That's a huge step forward, huge step forward. Okay, so you'll learn about templates. You'll be writing templates like what I just mentioned by the time you're done with 136. Okay, there are some little quirk things that are in templates that you have to get over, but essentially what you are doing is basically what I just said, passing in the data type. The rest of it is already canned. So that's what we mean by the term generic programming. You know that what you've done so far, whenever you work with integers, you can't just substitute character strings wherever there are integers, right? It just won't work that way. It just doesn't work. So with templates or with generic programming, we avoid or get around that issue. The cost of OOP, cost of object-oriented programming, hardware and low-level programmers have kind of drug their feet on the idea of C++, of object-oriented programming, because of the overhead involved. By that we mean the extra layer of abstraction. I want to just do it directly, make the assignment, done. I don't want to have to call and load in a class and have the class do that for me. This notion of abstraction, stepping one or two layers back from just assigning an integer value to something. We have to call some class, a setter for it. That code has to run in order to be able to make the assignment. So there is some overhead involved with this, but as we're learning, hardware folks and low-level programmers are relying on much faster machines that have much higher level kinds of instructions supported directly, and so this is becoming less and less of an issue. String class, I want to spend today talking about this. You don't get to use it yet. Okay? I'm going to talk about it. You don't get to use it in the lab for this week. You don't get to use it in the lab for next week. But after that, you get to use it. Okay? So it's coming. In 136, one of your assignments will be to write or rewrite your own version of the string class. So string class makes things easier. Okay? And I'm all about making your life easier, provided you understand what's under the hood. Okay? And that's what we're going to talk about today, is what is the string class? How is it constructed? What does it do for you? Predefined string class includes many of the components of OOP. That's why we use it. It's quite common these days in supported languages and object-oriented programming languages to have string classes. This is in VB. Many of you have had VB.NET before. It's an automatic part of VB. So string classes, very, very powerful, very extensive. I've highlighted the word encapsulated because encapsulation is a key component of object-oriented programming, of being able to do classes. Encapsulation, we encapsulate things in a class, and therefore the object has a shrink wrap around it and is isolated, is protected from outside invasion, if you will, or misuse. So a wrapper is a term we often use, and when we say wrapper, oh, this has got a wrapper around it, we are meaning encapsulation there. We've encapsulated something within a string class. In this case, the C string is encapsulated within the string class. Access to the C string is through its interface. We know that a C string is an array that is a contiguous chunk of memory cells, each byte of which contains one character. That's a C string. In addition, the null must be the last character, the last viable character in that array. Those are two critical definitions of what we mean by a string, a C string. In order to get access to it, what we've done is we understood what was under the hood. We counted bytes, we did string length, we did string compare, we did all kinds of nice little functions that actually counted and looked at and understood the underlying data structure, right? Forget to put the null there, and you don't have a string until somewhere way beyond where that array might be. Is that clear? So that's an issue, and with the string class, the only way that we can get to the string itself, is through its interface. So in order to make use of the string class, we have to include the special header file, string, just like IOStream and FStream and so on. We include string, and we have to follow the STD namespace rules for it. Examples now. We do the include here, and using std string, and all of a sudden we get this format. Notice the initialization that's introduced with C++. Certainly we could use the assignment operator, and this is not an assignment operation here at all, is it? In this line, it's an initialization because it appears on the same line as the data type declaration, and here's the variable definition. So this is an assignment operation, this equal sign is. This is, I'm sorry, not an assignment, it's an initialization operation setting fname to this. What will the length of fname be?
4.
Well, there'll be 4 bytes allocated, 1 for each letter plus the null, right?
Yeah.
So the length of the string is 3, there are 4 bytes allocated. So the array is 4 length, string is 3 length. Same thing here, same exact operation. So here we have really a 2-dimensional array, don't we? And possibly a ragged edged array. String, we don't know how big each one is. We don't know how big each one is, but we know we have an array of 25. We also know that if this were not a string class, this would be char star. Char star students 25, right? If we didn't use a string class. Therefore, this string class must be somehow supporting this char star or pointer to a character string. But we don't know that. We don't have to know that because of this encapsulation idea that the class presents for us, and we just simply call it a string. So the encapsulated in the string class is a C string data member. We can assume, and we can tell you now, that it is dynamically allocated. Each of those are dynamically allocated. If they're not initialized, the string class ensures that it is an empty string. And for printing of non-initialized strings, instead of printing some garbage, the C class, or the string class, assures us that we just simply don't print anything. It's part of what goes on inside of the class. It's encapsulated. Those checks and balances are done within the class. We can continue to use C in and C out, but we are going to be overloading. The C in and C out that's going to be in play will be very different subsets of the ones we know about already. We will be overloading the extraction and insertion operators. By the way, the extraction and insertion operators are already overloaded, aren't they? In native C, the angle bracket does what? In pure C, what does the angle bracket do?
Rotate or shifts.
For example, that one. Tyler?
Is it a bit shifting?
It's a shift. It's a left shift in this case, or a right shift. Bitwise left shift, bitwise right shift. So natively, this angle is a shift operator, okay? However, it's been overloaded in C++ for using it as an extraction or an insertion operator for C in and C out. And now we're going to overload it even more. We're going to overload it even more, or yet again, and we're going to identify this overloading by its context, the left and right parameters, namely C in, and the right parameter, the data type of what we have on the right. So here we have C in, F name. So F name we know it's a string data type. We know that it's a pointer to a string. We allocate, behind the scenes, we have to allocate enough memory for F name based on what gets typed in. With the C in here and the C in here, we're doing exactly the same thing. We have a char star, which is what an array is, right? An array is a char star, but it's a constant. Here it's a variable length based upon the dynamic allocation of what's been typed in. C out, we get F name and L name. Again, we traverse them up to the null, just as before, except now F name is a string type, not an array of character of a fixed length. It's a dynamic length array. For string class, we can't use the .getLine because .getLine is a whole different set that's not supported within the string class, number one. We can still use getLine as a non-member function. You notice here cout and in the previous slide cin, those become member functions of the string class. GetLine is not a supported member of the string class, and so we can't use it. It is a non-member function, so we still can use it, but we don't get the advantage of the string class operations from it. You've all done this stuff before, cin ignore and cin the get line, cin full name. It's all stuff you've seen before. We don't use string copy and string cat anymore once we're in the string class because the plus here and the equal have been overloaded. The plus equal is overloaded. That's a concatenation, isn't it? Notice that full name equals F name. The assignment is overloaded. So we do a string copy, not just an address copy, but a string copy, a deep copy here. The assignment operator is now overloaded for F name and full name being string class, so that it will do a string copy from here into here. Likewise, plus equals. Are we doing addition here? No, we're not doing addition at all. We're overloading the plus operator. And in those of you familiar with BASIC, BASIC has used the plus operator for concatenation for a long time and continues to do so. In this case, we're overloading the plus operator and making use of it as a concatenation. We're adding to full name the last name. Now we're comparing equal, comparing this string literal to the content of full name. That's a string compare. Doing a cout here, and what else? I guess that's about it for this one. So we have plus equals, string compare, and there are many other functions available. Before we get too far afield on this, I'd like to go through a couple of examples. always forget that when I double click, I get Visual Studio launched. In any event, here's a use of the string class, and in this particular example, here's a using namespace std. We're not allowed to do that in this class. You're aware of that, right? But if you want a shotgun and get everything in the known world, then by all means, using namespace std. Go for it. And live with the side effects that that also introduces. Okay? On the other hand, if you want to use a rifle to hit the target, then you'll explicitly say using std : and string, and that'll introduce a string class. Yes, sir?
For initialization, do you prefer the one with parentheses, quotes, man, or
The
equals?
habit that you, from this point forward, should be getting into is left and right parent, because that is the default standard, or de facto standard for C++. And when we are initializing classes, okay, that is the expected approach. There isn't syntax supported, actually, with the equal sign. So here we are declaring S1 to be of type string, S2 of type string, and S3 of type string. This one is initialized that way. That's a slightly different approach in terms of syntax. And then this one is uninitialized. Notice that we can assign S1 to S2, or S3, I mean. We can output S3, no problem. We can do a plus here where we are concatenating because the target here on the left-hand side is a string. This, and on the right-hand side of the equals is another string. These pluses are directly supported for concatenation. Concatenate this onto the back end of what we already have with S3. Can you all see that, or do I need to make that bigger? Can see it all right? Yes? No?
Up front I can, I don't know.
Kelvin, can you read it all right, or you need it bigger? You're okay? All right. So here we have another method invocation, s1.swap s2. So we are using s2 as the parameter of the swap member function of the string class, and we're using it for this object s1. Is that clear? We're passing to the class's member function the value of s2. So s1 owns swap and knows about swap, and so it's just swapping those two, copying one to the other, right? Pretty straight ahead kind of operation. And you can well imagine what you'd have to do to implement that, right? In this case, it's implemented for you already as part of the string class. Since I've got Visual Studio open already, I might as well stay there. See if I can open all of them at once. Let's look at this one, string assign. Did we already do? Oh, we already did that one. Sorry. String char. So built into the string class are things like the at function, things like the length function, things like the copy function. These are all just functions, but they are functions that belong to that class and are instantiated along with this object. Is that clear? Does that make some sense? So instead of having to call a function string length, we can simply say word.length after having instantiated word as being of type string class. So word.length is the string length, and word.at simply says, okay, so looking at word, I want the position, the jth position within it, and testing perhaps to see if it's out of bound. I want the value, the character that is at that position. Copying certain lengths